Okay, hi everyone, and welcome back. This is lesson 9. For today's lesson, we're gonna move away from factoring for just today. We're gonna go back to it, but today what we're going to do is we're going to learn how to identify the vertex and axis of symmetry of a quadratic function algebraically. Okay, so let's take a look at our learning goals. We can identify the roots, vertex, and axis of symmetry graphically, which we've already learned. We'll just review that. I can algebraically determine the vertex and axis of symmetry. And this is more for the practice. You can interpret the vertex point in the context of a real-world problem. Okay, so for the warm-up, we're just going to review the different components of a parabola, which is the graph of a quadratic function. So first we have the roots. Okay, so remember these are also called the zeros and the solutions. So these are located where the parabola hits the x-axis. So the parabola hits the x-axis at 2, 0 and 4, 0. So those are your two solutions. Okay, the vertex point is your turning point, right? Also known as your minimum or maximum point, okay? So here, since the parabola is pointed upwards towards this, it has a minimum point, and your vertex would be this point right here, which is 3, -1. So here we said, is this a minimum or maximum? Here, since it's pointed upwards, it's a minimum because it's its lowest point. If it was the other way, it would be a maximum because it would be the highest point. All right, and going back to our line of symmetry, so remember our line of symmetry is that invisible line here that breaks the parabola perfectly in half, okay? And your line of symmetry is this line that goes through your vertex point. So like I said last time, it's your x value of your vertex point. So that line would be x equals to 3. Because each point on this line, the x value is 3. So that is the equation of this line. So today we're going to learn how to get the vertex point and the line of symmetry algebraically. Okay, so we're going to move on to the next page. Okay, so finding the vertex and axis of symmetry algebraically. So it's not that difficult. We're going to use this equation right here. So to get the axis of symmetry, you use this equation, x equals to -b over 2a. So that means we need our b value of our equation and our a. So our first task is to find the vertex and axis of symmetry of f of x equals to -2x squared plus 4x plus 4. So the first step is we need our b and our a values. So just to make it easier, let's identify our a, b, and c. So our a is that first coefficient of x squared, which is -2. B is 4. And c is also 4. Okay. Next step. You want to substitute your b and a into x equals -b over 2a. So we have x equals negative. Our b value is 4 over 2 times your a value, which is -2. So let's simplify this. This becomes -4 over 2 times -2 is -4. And if we divide that, we get +1. So this means our vertex our axis of symmetry, the equation of our axis of symmetry is x equals to 1. Okay, so now, like I said previously, the x value of your axis of symmetry is the x value of the vertex point. So if we wanted to get the full vertex point, okay, we know our x value is 1. We just need our y. We don't know what that is. So in order to get the y value of the vertex, we would just substitute this x value into the function. So I'm just going to rewrite the function here. So it's f of x equals negative 2x squared I think it's plus 4x. I should have wrote that down there. Plus 4x plus 4. So what we're just going to do is we're going to substitute 1 to get the y value. So f of 1 would be negative 2 times 1 squared plus 4 times 1 plus 4. So wherever there's an x, you're just replacing it, you're substituting the 1. So let's evaluate this. Remember, we need to use order of operations. So f of 1 equals 2. First, we're going to do exponents. So 1 to the second power is 1 plus, I'm just writing everything out. Okay. Then we have multiplication. So negative 2 times 1 is negative 2. 4 times 1 is 4 plus 4. And then we just simply add everything together here. Negative 2 plus 4 is 2, plus 4 is 6. So that means our vertex point is 1, 6. Okay, so you use the negative b over 2a to get the axis of symmetry, which is the x value of the vertex, and then you just substitute it. Okay, just 2 more examples, and then you guys are going to do the practice. If you feel like you don't need these examples, you can move on straight to the practice. But for those who need the more support, continue watching. So your axis of symmetry. So you want to follow the steps I have on the first page. First thing you want to do is you want to identify your b and a, because those are the values you need. So your b here is 12, and your a is 3. So we're just going to substitute those values into the formula. So negative 12 over 2 times 3. So that becomes negative 12 over 2 times 3 is 6. And when you divide negative 12 divided by 6, you get negative 2. So our axis of symmetry is x equals negative 2. Okay? That's our equation of our axis of symmetry. Next, we want our vertex point. So from this formula, we know the x value is negative 2. We just need our y. Okay, so we're just going to substitute negative 2 into our formula. So I'm just going to rewrite it. Instead of x, I'm going to put negative 2. You can also put this expression directly into the calculator with the parentheses. It will work as well, but I'm just going to go step by step. Okay, so first we have exponents, so negative 2 squared. Make sure if you're using the calculator, you include the negative 2 in parentheses. So that's going to be positive 4, so it's going to be 3 times 4 plus 12 times negative 2 plus 6. 3 times 4 is 12. 12 times negative 2 is negative 24 plus 6. And then you just combine everything. So 12 minus 24 is negative 12, plus 6 is negative 6. So that means our y value of our vertex is negative 6. Okay, next, And also to verify, you could also graph to verify the point. You can use Desmos.com to graph it and verify that that's the vertex. Next, we have negative 2x squared plus 10x plus 4. So what's our b? Our b is 10. Our a is negative 2. Okay, and let's substitute that into our formula. So we have negative 10 over 2 times negative 2. So we have negative 10 over negative 4. And now you're going to get a decimal, but I would leave this as a fraction as 5 over 2. Okay, so we know the x value of our vertex is 5 over 2. Okay, so actually I'm going to write it like this. So our vertex line is 5 over 2, and that's the x value of our vertex, and that's our axis of symmetry equation. So we need the y value. So let's just substitute 5 over 2 into our equation. So f of 5 halves equals negative 2 times 5 over 2 squared plus 10 times 5 over 2 plus 4. I'm just going to grab my calculator. Okay, I got my calculator. So first we're going to do exponents. So we have negative 2 times 5 divided by 2 squared. That's 6.25 plus 10 times 5 over 2 plus 4. And I'm going to put this whole thing in my calculator. This way it just makes it easier with the parentheses as you see it. And if you don't have a calculator, you can like Google one. So that would be 16.5. So that would be our y value of our vertex. And now you're going to complete the Google form, which is the practice piece of this. And I hope you have a great day. See you for the next lesson.